In this video, we are discussing a super concept of rolling. So there is a round body which can be either solid sphere or which can be hollow sphere or anything, and this body is kept on a frictionless surface. So we need to apply some force or some impulse at a height h from the center, and we need to find out the value of h for which this round body would be rolling purely on this surface. So this is a super concept of rotational motion, and we know that without any rolling friction, let's suppose we have applied some impulse at this point which is at a height of h from the center. So this impulse is producing change in momentum. So this impulse is equal to change in momentum, which is mv, and this object was initially at rest. So the change in momentum is m into v, where v is the velocity with which it starts to roll. Now the angular impulse. If we talk about angular impulse about center, so angular impulse about O is equal to linear impulse into distance from O, which is J into H. And this angular impulse is also equal to the change in angular momentum about O, delta L about O. So this is J into H is equal to I omega, and omega is the angular velocity of this object about center, and I is its moment of inertia. Now this J into H is equal to I, where I is m k square, where k is radius of gyration, because I don't know, or we don't know, that what is this body. Is this a solid sphere, or is this a hollow sphere, or is this a ring? So we can generalize this formula in terms of radius of gyration k. So J into H is equal to mk square omega, where J is equal to m into v. So we can substitute J as m into v, and this is H is equal to mk square omega, and cancelling this m with m. Now we know that for pure rolling, omega is equal to v upon r. So v into h is equal to k square into v upon r, and cancelling v with v. So this h is equal to k square upon r, which means if we apply this force or impulse at a height of k square by r for this object, then it would roll purely without any requirement of rolling friction, and it would roll purely on frictionless surface also. So if this is or we can say that for solid sphere, we know that for solid sphere k is equal to under root of 2 by 5 of r. So h is equal to 2 by 5 of r. You can substitute this value of k in this equation, and for hollow sphere, we know that k is equal to root of 2 by 3 of r. So this h is equal to 2 by 3 of r. So likewise, we can substitute the value of k in according to the body which is given in the question, and we can directly memorize this formula. So for disk it is r by 2, for ring it is r, for solid sphere it is 2 by 5 r, for hollow sphere it is 2 by 3 r, and so on. So this was the super concept of rolling, and I'll be bringing more super concepts about rotational motion in the next videos. Thank you.